In this video, we'll take you on a journey with our anaerobic digester, Fidel Gastro, as we explore the challenges, lessons, and discoveries we encountered along the way. Throughout this project, we've come to realize that mistakes are inevitable and part of the hands-on experimentation process. From occasional spills of smelly liquid while feeding or extracting, to more significant mishaps that impacted the reactor's performance. Each experience taught us something valuable. One notable incident occurred when we inserted the feeding tube too far into the reactor. This caused the biogas bag to nearly deflate completely, disturbing the system. After refilling the bag with CO2, it took about 8 full days for the reactor to return to normal operation, showing just how sensitive the system can be to disturbances. This experience highlighted the importance of precision and careful handling when working with an anaerobic digester. In our efforts to understand what really impacted reactor performance and stability, we found that temperature didn't play as a significant role as long as it was high enough. Instead, pH stability proved to be crucial. At the start of our experiment, stabilizing the pH was essential for achieving optimal biogas production, but this proved to be more challenging than anticipated. We initially attempted to balance the pH using calcium carbonate, but it didn't provide the results we needed. After multiple attempts, we switched to sodium hydroxide, adding around 4 liters of sodium hydroxide solution of various strengths to bring the pH to a satisfactory level. It took significantly more base than we expected, highlighting just how resistant the system was to pH adjustments. Once we finally achieved a stable pH, the digester's efficiency improved noticeably. Biogas production increased steadily, eventually reaching our peak output of 10 liters for the first time. This experience highlighted the importance of pH stability in an anaerobic digester. A stable pH fosters an environment where microbial activity can thrive, maximizing gas production and overall system efficiency. At the start of our experiment, while using the 4% solids feed, we observed the trend of the gas readings frequently reaching the 10-liter maximum capacity. This wasn't ideal as it led to unusable data due to the consistent overflow. To address this, we decided to change the feed to 3% solids, which resulted in a small but noticeable decrease in biogas yield, helping us to collect more manageable data. Later on, we modified the feed again, incorporating a 30% white bread into the mixture. This change had an interesting impact on the smell emitted from the reactor, even though the gas composition remained relatively consistent, particularly with the sulfur content staying the same. Interestingly, our reactor produced significantly less sulfur than the other reactors in the study, which raised the question about the interactions between feed components and sulfur production. In our group's analysis, we observed that the hydrogen sulfide production was around 1 part per million, notably lower compared to the other groups, whose systems produced significantly higher levels. This discrepancy is intriguing and warrants further investigation to fully understand how the feed composition influences both gas yield and odor characteristics. It's particularly interesting that, despite the significantly lower sulfur content, our system exhibited a similar smell to the others, suggesting that factors beyond just hydrogen sulfide concentration may be contributing to the odor profile. This finding opens up avenues for deeper exploration into the complex interactions within the feed and production system. Just as Fidel Castro's passion for smoking and anarchy drove him to defy convention, we too found ourselves drawn to a similar, rebellious curiosity, albeit with good intentions, with our reactor Fidel Gastro. This led us to experiment with burning the biogas we produced, seeking to uncover its potential and explore its unique characteristics. In our little side experiment, we examined the impact of diluting biogas with an addition of CO2 and N2. We found that the low methane content in the biogas requires a higher flow rate to sustain a flame. CO2 in particular seemed to absorb more heat than the N2, meaning that a high CO2 content results in an unsustained flame. Additionally, while extra N2 caused flame detachment, this issue could potentially be resolved with improved air mixing. These observations indicate that further experimentation is needed to fully understand these effects. Biogas burners require much higher pressure to generate a sufficient flame for heating purposes. Our small setup, with a relatively low pressure, struggled to direct enough heat to the pot. Increasing the flame size by raising the biogas flow rate only shortened the flame length, concentrating more heat on the burner itself rather than on the intended target. One positive outcome was that the biogas could be mixed with air effectively at low pressures. This observation is promising, as it points to the potential of creating a safe, small-scale biogas burner that won't pose a carbon monoxide risk for the user. The experiment also suggested that any aerobic activity within the reactor would render the biogas ineffective, as it would reduce the methane content. However, with careful control, burners could still function effectively at small scales. It was noted that a larger gas storage bag might help achieve higher pressures, which could improve burner performance. Additionally, using materials like copper for the burner could be problematic, as the heat from the biogas flame can soften the copper tip. Given that biogas composition can vary significantly, it's also crucial to incorporate adjustability in the air mixing process. This is especially important for achieving the right flame characteristics under different pressure conditions to make the burner work. As we conclude our journey with our anaerobic digester, Fidel Gastro, it's clear that this project has been both a challenge and a rewarding learning experience. The more we know about the intricacies of biogas production, reactor stability, and the influence of feed composition, the more we realize how much remains to be uncovered. This fun and enlightening journey has not only expanded our understanding of anaerobic digesters, but also sparked curiosity for further investigations into the complex interactions that drive these systems.